This is part 2 of our lesson on transformations. This time we're going to look at a slightly different function. We've got y equals 1/2 x plus 5 squared plus 3. So the first thing we want to do is list our transformations. The plus 3 is going to go up 3. That x plus 5 there, that plus 5 is going to go left 5. And the 1/2 is a compression of 2. So what we're going to do is start with the basic parabola y equals x squared, which has a vertex at 0, 0. So we're going to move left 5 and up 3 to find the vertex of this parabola. So 1, 2, 3, 4, 5 to the left and 3 up. There's the vertex at -5, +3, so I can fill that in the table. And then to graph the rest of the parabola, I'm going to take a look at my regular step pattern, which is 1, 3, 5, 7, 9. But this time it's a compression of 2. So we're going to take all of our values and we're going to squish them down, okay, so that they're 2 times smaller than before. So I'm going to do that by dividing by 2. So I'm going to take 1 divided by 2, and I could write 1/2, but I think I'm going to use the decimal 0.5. It'll be a little easier to graph. And then 3 divided by 2 is 1.5, 5 divided by 2 is 2.5, 7 divided by 2 is 3.5, and 9 divided by 2 is 4.5. So from our vertex, we're going to start by going over 1 and up 1/2. And then over 1 and up 1.5. So the half is just up to the next square, and then 1 more past that. And then over 1 up 2.5. And over 1 and up the half, and then another 3 for 3.5. And I don't think I can go any further. So then we do the same points on the other side. So up 1/2, 1.5, 2.5, 3.5. And then we just draw in our parabola all the way to the end of the grid, arrows on the end to show that it keeps going. Now if I take a look at the axis of symmetry once again, that's going to cut it straight down the middle through the vertex. So it's going to be x equals -5. Our maximum or minimum, this has a minimum, a lowest point this time. And our minimum value is 3. For the domain is always the same for the parabola. It's heading off to -infinity on this side and +infinity on this side. So x is all the numbers between -infinity and +infinity. So we write xer, and then -infinity to +infinity. X is all the numbers in between, and then our arrows point towards the smallest number, which is the -infinity. Now you can put the equal signs on, but really you can't ever get to infinity, so we shouldn't put them there. To do the range, we're going to look at our lowest point, which in this case would be 3, and then our highest point, which is going to be infinity. So our graph here is all the y values between 3 and infinity. So I'm going to write YER, and then 3 and infinity, and y is all the numbers in between, and then our less than, greater than signs are going to point towards the smaller number, which is 3, and I put the equal sign on 3, and you can put the equal sign for infinity, but we probably shouldn't. And that's what our graph should look like. Now there is one last question here, which is to find the equation of a function given the graph. So it says determine the equation of the function shown on the graph below. And what I need to do is think about what I did when I graphed. First, we usually find the vertex, and then we use the step pattern to find the remaining points. So the same thing here, I'm going to find my vertex, and then I'm going to see if I can try to count out what the step pattern is to see whether I've stretched or compressed, and by how much. So the vertex of this graph is -2 and -6, which means that the graph has gone left 2 and down 6. So that's at least going to help me figure out my h and k. And then I'm going to try to count out the step pattern every time we go over 1 and then up or down. So we definitely went over 1, and it looks like we went up 3, and then over 1, and 1, 2, 3, 4, 5, 6, 7, 8. Could be 8 or 9. I'm thinking because of the 3, it's probably a 9. And then I can't tell past that because there isn't another point that I can see. So my step pattern here is 3 and then 9. And normally my step pattern is 1, 3, 5, 7, 9. Which means it looks to me like we have multiplied our step pattern by 3, which would be a stretch of 3. Now it's not upside down, so it's not a reflection. So I'm going to try to write my equation. We're going to say y equals, and normally the equation follows the pattern a, x plus h squared plus k. So the a is going to be my stretch, so that's the 3. And then I have x plus h. Well, we're going left 2, so left 2 is a plus 2. If we were going right 2, we would have done minus 2, and then a square. And the plus k, we're going down 6, so we're actually going to subtract 6. And there's my equation.